So now, we're really just doing the same thing as last lesson, but using difference of squares to factor it. And you'll see that it takes us just a little bit further when we have to continue factoring, that last step in factoring where we say, hey, can we still factor? Maybe there's a common factor or a difference of squares. So again, yeah, we've got maybe two expressions instead of just single variables that we're using. And just to remind us that our factors, our expressions here can be more than just a variable, right? So maybe f of x is something like x squared minus sine x over 2 plus x, right? That could be anything. We won't get that nasty. Here we go. So here, oh, that's a square, so we have 3x plus 4y and 3x minus 4y. So as long as it's a square, we can do it. Notice that in b, and neither of those expressions are squares, but we can always pull out our common factor. And in this case, each of them have a 3. Both of them have at least one x, and both of them have at least one y. When we factor out the 3xy, we're left with x squared minus 9y squared. So we continue factoring. Okay, and we get those 1, 2, 3, 4, 5 factors. That's a lot. Now, both of these are perfect squares, but we should always look for common factors first. Okay, so I noticed that 4 also goes into 144, right? I've got to think for a second. That's going to be 3 times 12, so I think it's 4 times 36. Sounds right. So I'm going to pull out the 4, and then I have 36 p squared q squared minus r squared. My thing is misbehaving. 4, 6pq plus r. You can see that it's really easy to make a mistake here. I've often, accidentally added the square, right? And students do this pretty frequently too, where, and so this is one of the things that we can check after, right? PQ plus R. We can multiply this back out, right? And we're usually pretty good at multiplying out and just see if we get the same as our leading response here. Now, if we have a pane of glass, here we've got a word problem. If we have a pane of glass that's rectangular, so let's look at that here. Length times width. And we want the area is given, so the area is equal to that expression. The length and width of the pane of glass can both be written in the form ax plus by, where a and b are integers. Determine the appropriate values for a and b, and hence write expressions for x and y for the length and width of the pane. Okay, so we can factor that. A equals L times W. So we have 49x squared minus 16y squared is equal to 2 factors. Well, 7x plus 8, oh, not 8. That's easy to make a mistake like that. 7x minus 4y. There we go. And then we just want to know expressions. So here, length can be 7x plus 4y, and the width is equal to 7x minus 4y. Given that the length of the pane is double the width, and the perimeter is 56. Okay, so we've got a lot of information here. Length is double the width. Okay, 7x plus 4y is equal to 2 times 7x minus 4y. Okay, so let's multiply this out and see what we get. 7x plus 4y is equal to 14x minus 8y. Yeah, there's no real way to solve for that, but let's keep going here. Let's try this perimeter thing. Perimeter is equal to 2L plus 2W, right? I just add up all the sides of my rectangle. So if we have 56, is equal to 2 times 7x plus 4y. And what was the other one? Plus 2 times 7x minus 4y. Can we solve for one of those variables? Because we really just want to know what those are. So that's going to be 14x plus 8y plus 14x minus 8y. Oh, that's great. We can just cancel those out. So now we have 28x equals 56. So now we know that x is 2, but remember, it didn't ask us what x is equal to. We just want to know what the length and width are. There's actually a shorter way to do this, but I thought we'd use our expressions and play with them a little bit. So if x is 2, let's substitute that in. 7 times 2 plus 4y equals 14 times 2 minus 8y. I've effectively gotten rid of one of my variables, so now I just have one variable. I'm going to bring my y's to their left so that they can be positive. I like having positive values. So now I have 14 plus 12y equals 28. 12y equals 14, and y is equal to 14 over 12, or 7 over 6. That means my length is equal to 7 times 2 plus 4 times 7 over 6, which is 14 plus 14 over 3. I feel like I've made a mistake here somewhere. 14, 28. Doesn't look too bad, actually. Anyway, maybe I did. That's fine. I'm not afraid of mistakes. No one's life is in danger. All right, 3 times 14 is 42 plus 14. What's 42 plus 14? 56 over 3. And we know that the length is twice the width. So that's the length. The width is going to be half that. So width is equal to 28 over 3. 1, 2, 3. 1, 2, 3. Yeah, that will work. So there we go. There is another way of solving this, and if you found it, please come and let me know. Okay, let's factor this one. Here we have a difference of squares, right? K to the 4 is k squared times k squared, and 1 times 1, and the negative. But we can't leave it like that. That is also a difference of squares, so we're going to do this. K plus 1, k minus 1. Now, inevitably, someone asks, why can't I factor the k squared plus 1? Well, it's not a difference of squares, and you can't find any numbers that multiply to get a square plus 1. This is actually a mathematical proof that people do, right? So if you take any number, let's say 5 squared plus 1, right? There's no general formula for this, right? So that's just 26. Yeah, we could multiply a whole bunch of numbers, but is there a general rule for x squared plus 1? Or x squared plus anything, right? There's no way to make sure. When we have a difference of squares, though, there is that general formula, right? So that we've been factoring with. There we go, that's done. This one, these are not perfect squares. So let's pull out that common factor of 5. 5 times 16 is 80. A to the 4 minus x to the 4. Then we have our difference of squares, so 5, 4a squared minus x squared. Oh, I think I know where this is going now. Plus x squared. And another difference of squares, so we have 5, 2a plus x, 2a minus x, 4a squared plus x squared. All right, and there we go. That's some good factoring. I'll let you do a C there. And let's factor this one. Here we have an a squared, but here we have a binomial that's squared. So let's use some bigger brackets. This is a difference of squares, right? Square, square. A and a plus minus, and then I have to put brackets around my binomial. But it's not proper to leave it like that, so we're going to change it, or drop the brackets. So a plus b minus c, and a minus b plus c. All right. This one's going to be quite interesting because we have another we have another difference of squares, but we have two binomials. So let's see what this looks like. So we've got, I'm going to use square brackets because I'm going to use a lot of round brackets inside. So I have 2x minus y plus, and 2x minus y minus x plus y, x plus y. So now we have 2x plus x is 3x, and then negative y plus y cancel out. So we have 3x. Then we have 2x minus x is x, and negative y minus y is minus 2y. See how that cleans up nicely? That's a lot faster. I just want to show you the difference here. If I were to multiply this out, I'd say 4x squared minus 4xy plus y squared minus x squared plus 2xy plus y squared. And I could do this in an extra step as well, right? Then I'm going to add all my x squares together. I have 5x squared. No, that's not 5. It's 3. 3x squared. Then I have minus 6xy, right? You can see why. I'm subtracting this 2xy. And then the y squared minus y squared, gone. So then I've got to take apart my common factor, 3x, and say x minus 2y. So that's the same thing, but having to multiply these out, kind of a drag. Well, one last one before you go home. Wait, you're already home. Let's again use big brackets. We have 6x plus 5, and I know these are difference of squares. Again, check the sign. And plus 7 times x minus 8. And then we'll have 6 times x plus 5 minus 7 x minus 8. 6x plus 30 plus 7x minus 56. 6x plus 30 minus 7x plus 56. Okay, you can see the difference is right there. Oh, and I guess there too. Now let's add our like terms. We have 13x minus 26. And we have negative x plus 86. Now, can we clean this up? Well, yeah. If we look at this, we have a common factor, 13, x minus 2. And over here, I'm going to pull out the negative. I'm going to take that negative right here, and I'm going to put it out in front. So I have x minus 86. I factored out the negative 1. And this is probably your better set of factors.